Ladies and gentlemen, please welcome to the stage CloudBee's Vice President of Marketing, Andre Pino.
That was Nigel Stanford. What did you think of that? Nigel is a developer and a musician, and he's doing amazing things combining both of those talents. So welcome back. What did you think of day one? Well, I hope you had a great time and learned a lot yesterday and had a great time at the party. We've got an amazing day two prepared for you. And there's just a couple of things that I wanted to highlight for you. Number one, make sure you take your artistic talent and apply it to the mural that's being colored in out in the major hallway out there, because that's going to get completed this afternoon. So you'll definitely want to do that, get a selfie, and make sure you can point out to the little red dot that you put into that mural. We also want to highlight the Women in Tech Lunch that'll take place today. All are welcome. And I want to remind you about the closing session that starts this afternoon at 4:30. So come on in, grab a beer. We're going to have a wonderful keynote by Dr. Nicole Forsgren. She's going to be talking about what the data says about high-performing DevOps teams. So that'll be really interesting. And then afterward, we're going to have some really fantastic prizes, but you've got to be present to win, so make sure that you're here. Kicking off today, as I mentioned, Amazon Web Services is our showcase sponsor. And so we've got a keynote this morning by Amazon. And so Justin Graham, Senior Manager, Market Strategy and Ecosystem Development for Amazon Web Services is here. Justin leads market strategy and the ecosystem development for AWS Container Services and Amazon Linux, and advocates changing the way companies architect applications and make the most efficient use of compute infrastructure. Please join me in welcoming Justin Graham to the stage.
Thanks, Andre. Good morning, everyone. How are you? Woo! Oh, that's a lot of energy for 8:30 in the morning after a party last night. Good. Glad that you could make it. So for me, actually, it's somewhere between 8:30 in the morning and 1 in the morning, because I was in Australia last week. So my body's sort of in the middle of making that transition. So I want to talk to you this morning about accelerating your transition to modern and cloud-native applications, because we're seeing this as a really important transition that a lot of companies are starting to embark on, and there's a really big role to play for both developers and operators in this transition. So we'll start there and we'll move through that. Just a quick shout out to CloudBees for having us here, and especially Jeff Fry and Jason Miro. We had a big idea of doing a bit of a selfie thing in the morning with this keynote to pump my Instagram stats, but that got a little bit nixed, so hopefully you'll bear with me. But follow me on Instagram or Twitter if you like travel pics. All right, so let's start off by defining what cloud-native applications and modern applications consist of. I give this talk a couple times in smaller groups, and one of the things I notice is as trends sort of start off with their getting popular, those terms start off being really well defined, and people know what they mean. But then as those terms and these things get more popular and more popular, sometimes these terms get diluted a bit and they sort of mean everything and nothing at the same time. So let's start with defining this. The first primitive, or the first key primitive of a cloud-native application is container-based. And we make that assertion for a very good and interesting reason, because containers are the primitive that really allow applications to be packaged, allow applications to be portable, reproducible, transparent, and isolated as a resource from other things. So we think if you really are going to embark on this, this is a key primitive that you should adopt and look into, and there's obviously many great tools to do that and get that started. The second key primitive of cloud-native applications is dynamically managed or dynamic management. And this is where things like container orchestration come in, where the system or managing your infrastructure as a system comes in, and I'll talk about that a little bit later. And application containers work really well with this key primitive because container orchestration and other management tools really have some of the great capabilities like scheduling, hydration, et cetera, that can really help make this a reality for you. The third is microservices oriented. Has anyone not heard of the term microservices in the audience? Raise of hands. Okay, so everyone's heard that term. It's a really different way of thinking about architecting your applications from three-tier, as opposed to three-tier architectures. And it's something that we think, compared and contrasted with the other two, really matters a lot in achieving the benefits of cloud-native applications. Breaking those applications down into their smallest atomic parts and allowing them to scale independently of one another as needed. So now that we have those three key primitives defined, now let's talk about the key building blocks for all of you to be successful in making that transition to cloud-native applications. So the first, no surprise, is containers, and we'll talk about that. The second is cloud. And we really believe that this is, for obvious reasons, I work for AWS, so that's part of it, but we really believe that cloud enables some key things that are just not really possible if you're running on-prem, and we'll talk a little bit about that. And then the third is culture. And culture matters just as much, if not more, than the other two pieces. And it really is something that I'd love all of you to sort of walk away thinking about how your culture, how you're organized, really affects your ability to have a key for success and make this transition. So we'll talk a little bit about that as well. So kind of looking across this continuum, one thing as I was preparing for this talk that really struck me was there's a really interesting rubric that is followed on almost all sort of technology transitions, and that's people, process, technology. And if you think about containers, cloud, culture, that really fits well with the rubric of people, process, technology. And all of these three things are involved really deeply when you're trying to make a transition, a technology transition or an innovation transition at any point in your company or in your life cycle. They're all very important. So let's start off by talking about containers. And DevOps is a really, really important part of the technology, is important process that's a part of this technology when you're trying to adopt things like containers. And the DORA report, which I think hopefully many of you have read or seen, but if not, you should. It's got a bunch of very, very interesting data in it. But the key point of that report all up is there are companies who move very quickly through people, process, and technology and culture. And there's companies that haven't adopted some of these principles that are quite a bit slower. And the ones that take advantage of these are quite a bit faster than the ones that don't. When I first saw the number 2555x, I sort of think that's a really big number. Is that really feasible? What's behind that? But the data really proves this out. And when you take a look at some of the other data behind that, what really comes out to you is at the end of the day, we all work for a company that provides value to our customers. And our primary goal is to provide that value as fast as possible and to iterate that value to customers as fast as possible. And today's a different day. If your customers feel like you're not providing that value, they can very easily vote with their feet and move to one of your competitors or a different company that provides a different service. and move relatively quickly with relatively low things that they're giving up to make that move. One of the case studies we talk about a lot is one with one of our customers, McDonald's, who used containers and a couple of other pieces of technology around containers to help deliver their food through some newer apps like Uber Eats, Postmates, et cetera. So that is a really powerful story, and I'd be happy to elaborate a little more with you offline. But that's a demonstration of how taking containers technology and pairing that with some other process and culture really helps. So now that we've sort of proven that point, now let's move on to talking about how containers really help to affect this journey. And I'm assuming all of us here at some point in our career have worked with, in or around virtual machines. If you haven't, this is not the presentation that's going to help. When we're making these types of technology transitions, one of the things in a new technology is, as it's starting off, a lot of times folks will lean on the technology knowledge that they had prior to help them understand or adopt a new piece of technology. So for myself, I'm sorry, developers, this is not going to make you feel great, but I come from the infrastructure background, so I used to design networks and infrastructures and deployments and things along those lines. So coming into the containers world, I leaned on that knowledge of virtual machines and infrastructure to help me understand this, this primitive. But we need to move beyond leaning containers onto older primitives like virtual machines and treat them as first-class citizens. So the first things that we need to do that is to realize containers as a separate and autonomous compute primitive. So one of the things that we think and that we've been working on is how do we separate the container from other pieces of compute and make it its own native core piece of compute such that it's easier for infrastructure operators, developers, DevOps practitioners to take advantage of those things. The second is networking. And if you remember, if those of us who were around back when virtual machines started, remember there was a point in time where you couldn't attach an IP address directly to a virtual machine. You had to attach it to the host and then bridge your networking, and that caused all kinds of issues for developers because they had to figure out how to develop around that. Eventually, that problem got solved. The same thing's happening with containers, by the way. So the ability to attach networking directly to a container makes it an atomic unit that separates itself from all of the underlying infrastructure, which makes it easier for you as developers, but also easier for operators as well to provide a robust service using containers as a core primitive. The third is permissions. And permissions, managing access to the container as a primitive and at the service level, not just the host level. So a lot of work has gone into adjusting permissions and securities and security rules and groupings to attach directly to containers. And the last is monitoring and logging, and thinking about how we can create new API platforms to make logs, metrics, and what's happening with your application tied to the container that it's running within and not the host that it's running upon. So if we're successful in making containers a first-class citizen, that makes lives for all of you as developers and operators quite a bit easier. So one of the things we thought of at AWS a bit ago was how do we help you focus more on your app and the core primitive that it runs within and nothing else behind that. Last year, we released a technology called Fargate, which was an interesting model to think about, which is, hey, what if you as a developer wanting to run on the containers or an app on the cloud didn't have to think about anything except your app code and your container and some rules around how you wanted your app to be run. But everything else behind that was taken care of for you. You didn't have to worry about an operating system. You didn't have to worry about choosing an instance type or how big or small it needed to be. You didn't need to worry about managing that OS or installing a runtime or installing agents. All you needed to do was hand your app and your container over and have it run on your behalf. What would the world look like if that happened? And then we built something that delivered that and then only charged you for the resources that you provisioned within it, and then allowed you to raise that level of abstraction and raise that level of focus just on your application. So we've had some pretty powerful stories around folks diving in early and using something like, and using Fargate to help them redirect that focus. And we think that this is a really, really important thing to think about for you as operators, practitioners, which is providing that platform to your developers and to your teams to help them only focus on what really matters. So driving to focus on what matters for your customers. So as we go through this, I'll recap 4 principles of cloud-native applications. And the first is enabling you to ship features faster without worrying about the collateral damage of failure. And I think that that last piece really, really matters. And when we think about the unlock for innovation and the unlock for speed and the unlock for new ideas. If you don't have to, if you can iterate and you don't have to pre-provision a bunch of hardware or spend a bunch of money up front, which we'll get to, and something doesn't work out or you need to go a different direction, you don't want to be saddled with all of that collateral damage of failure. So this is a big unlock that we think is important. So next, let's talk about how cloud plays into that piece as well. So a little recap of how we think about the benefits of a cloud-native architecture. The first is pay as you go, and that may sound really simple, which is, okay, I only want to pay for what I'm using at the time that I'm using it, but there's a couple of other nuances to that that also matter that I want to cover. The second is self-service and API-driven, and I think for the most part, this really applies to how folks who operators, infrastructure architects, really change the way we think and what we deliver on behalf of our developers and our customers. And the third is elasticity and scalability, which we believe is something that is inherent to running in the cloud, and I'll talk a little bit about that in a second. So the first piece is in data centers, if you're running your own colos, you're running your own hardware, there's a key limitation that we believe that you have, which is at some point there is a finite amount of resource that you've purchased, installed, provisioned that is always in the back of your mind as a developer or always in the back of your mind as an infrastructure architect. And then separately from that, you're also worrying about the life cycle of all of those things. How often do I have to refresh that hardware? How often do I have to refresh the racks that are in it, the equipment, everything along those lines. So there's always something in the back of your mind that you're thinking about, and if you feel like you need more resource or more provisioning, there's a process that has to happen. And most of the time, you have to think about and make that expenditure up front before you realize the value that expenditure or that infrastructure can provide you. When you're running in the cloud, you're paying a month later for the number of seconds or minutes that you used in the month that just passed. And that's a very, very different way of thinking. So imagine if you're sitting in your dorm room, or you're sitting in your garage, or in the airport, which is where I spend a lot of my time, and you have an idea. You can actually prove value for that idea before having to really expend any money behind that value. So if you write a new app, deploy that app, test it, you can actually get to a point where you say, hey, if something works here, I may be onto something before you actually have to think about it making an expenditure. Or you have to think about reconfiguring a bunch of things or anything along those lines. If you're running on-prem, a lot of times you actually have to think about what you may need in the future, try to guess what that is, make that expenditure ahead of time, and then if that iteration happens or it doesn't work out or you need to shift, then you're saddled with that expenditure and you have to figure out what to do with it afterwards. There's also another key important mindset thing that happens here, which is, and we can even take this down to personal finances. When you spend money on something or anything, there's a little mental thing that says, okay, I've spent this money, I have to figure out from now moving forward how I make sure I get the most out of that money I already spent, right? So there's a mental thing which says, okay, well, hey, we spent millions of dollars on this hardware, it's going to depreciate over 3 or 4 years. How do we get the most value out of that money? And it changes the way that you think about how to use that expenditure, how you plan against that expenditure, just a little bit. And in some places, more than just a little bit. It's a different mindset when you're thinking about, okay, I haven't expended any money yet. I can choose what I use. I can figure out where the value is over rapid iteration. And then at the end of the day, if it doesn't work out, I can shut it off, only pay for what I use, and I'm not saddled with anything in the future, and I can move on to something different. So the second principle is pay for what you used last month, not guess what you'll need to use next year, but also using that to enable your teams to experiment, fail fast, and hopefully fail forward, not fail backwards, without significant investment or expenditure. The next part of the principle has to do with thinking about process and thinking about what our jobs as operators or DevOps practitioners really mean. And I remember the world where I was an operator and I was helping operators, and every time a developer on my, upstream from me or on the team that I was helping needed a change to the infrastructure or a change to the dev environment, they filed a ticket. And then we as infrastructure operators would pick that ticket up, triage that ticket, and then we would respond most of the time on a ticket-by-ticket basis. So, okay, this ticket says we need more compute. Do we have servers, on hand? Do we have to order some? This developer needs a different version of software. Do we already own it? Do we have to think about that? Do we have to go procure it? How do we install it? Moving from that world to a self-service world is a different mindset. And as DevOps practitioners and infrastructure professionals, it means changing the way that we think about what we deliver for our developers to work against and ultimately what our customers run against, which is a self-service platform or a system of infrastructure rather than just pieces of infrastructure that do different things or that are sliced off for different reasons. So deployments, by making APIs and self-service calls that happen quickly within minutes with little human interaction that enjoy a lot of automation versus filing tickets and waiting for humans to take action against those individual tickets. So it's a mindset of changing what we do to managing a system and creating a system for deployments and a system for developers to operate against and then us operating against that system rather than responding to individual tickets here and there. This is where we're really proud of the work that we've done together with CloudBees, especially around our launch of Amazon EKS, which is our managed Kubernetes service. We really are embracing what Kubernetes has to offer, and we really believe that working with CloudBees, all of you are here because you're, I'm assuming, large users of Jenkins, large users of CloudBees Core, and other CloudBees offerings, and we truly believe that containers themselves are in the center of a very long tool chain. And in the front of that tool chain, there's development tools, and behind it, there's CI tools, CD tools that need to that help get that code to market quickly and efficiently. And container infrastructures can't operate well and efficiently without CI and CD attached to them on the back end. So if you're using CloudBees Jenkins and you're interested in getting to know and use container infrastructures and Kubernetes, there's a really good set of tools that work really well together for you that I'd encourage you to investigate. And you can do that on your own. So I would really recommend you do that. So the third principle, finishing on this section, is self-service, API-driven, automation, and move yourselves from thinking about how do I respond on a ticket-by-ticket basis and change on a ticket-by-ticket basis to how do I create a system and how do I triage the tickets that are coming in or the changes that are being asked and apply those in groups or in aggregate to changing the system that delivers code on behalf of developers and your customers. So the next part of the principle, which cloud helps with, is resiliency. There's three pieces here, but I'm going to spend a lot of time talking on just one of them, which is blast radius. And a lot of operating in the cloud and a lot of what we do as operators or a lot of what we do as developers is how do we reduce the blast radius in case something goes wrong? And I'll even edit myself and say, not in case something goes wrong, when something goes wrong. Because failure will happen. We're all human. We can't account for every angle or every possible thing that will happen. So at the end of the day, when something does go wrong, how do we ensure that it affects the least amount of customers possible or the least amount of fallout possible, but have it recover as quickly as possible, ideally without a lot or any human interaction. So we spend a lot of time thinking about this when we design services and when we design our operational bar as well. And it's something that we encourage others to think about when you're thinking about how do you architect your infrastructures or applications. And by running in the cloud, there's a whole bunch of things that sit behind you or that are available for you to use that would be really difficult to replicate, such as the last thing, geographic distribution and high availability. So for instance, if you deploy an app to a region, an AWS region, all of our standard regions are have 3 availability zones. So you can stretch your app across more than one availability zone within a geographic region. And if I flip back to talking to you about Amazon EKS, which is our managed Kubernetes service, we take advantage of that on your behalf. So if you deploy a Kubernetes cluster through EKS, by default, it is highly available, and we stretch control plane components for Kubernetes across 2 availability zones for you by default. So what that means for you, as an example, is if you need to upgrade your Kubernetes version, you can do that in a rolling way such that your control plane is available through the whole time that you're upgrading your underlying Kubernetes infrastructure. So your app is still available to your customers. So that's one example of something in the cloud that's available for you all the time that would be really tough to replicate otherwise, and we encourage you to take advantage of it. Now when we go take those things and apply them to the microservices constructs, we firmly believe that microservices are the key design principle or design pattern that will help you limit the blast radius for software incidents. Because if you're taking your app and you're breaking it down into the smallest, most core components that are possible, the example I like to use is taking a user account, user authentication system from a monolith to breaking it down to the smallest core components, which could be account creation, account deletion, delivering a login page, checking credentials against a database. All of those things can be broken down into individual components. Those individual components can scale up or down as they need, as the demand warrants. But also, if one of those components fails, it doesn't affect the other components. And the other components can continue to operate as they need to without being affected by a failure on one. And that failure could be due to a number of reasons. So by separating your app components into microservices, you can build and deploy those loosely coupled services move quickly, and isolate any potential failures from one another using that construct and that pattern. All right. So, principle 4, use microservices to reduce blast radius, loosely coupled services, and support highly distributed deployments in an isolated way. So I'll finish by talking to you about culture, and I'll just touch on a few quotes that I think are my favorite quotes. So Adrian Cockcroft, for those of you who may not know who Adrian is, he's way more famous than I do. His Instagram stats are way better than mine. Worked at Netflix, now works for us at AWS, and talks about the culture of innovation. And a lot of times I hear customers and folks talk about, how do I inject more innovation into my company? How do I innovate more? And trying to focus on how do I innovate. Innovation comes from passion, innovation comes from creativity, and I usually talk about hiring and staffing folks that are creative, passionate, and really care about customers. And then all of our jobs around that creativity is to put the infrastructure and the tools and everything in place to make sure that innovation can grow, flourish at speed, and then just get out of the way. So our job is not to feed the innovation. Our job is to provide it the care and feeding that it needs and get out of its way. Before I go to this, there's another quote that I love. If everyone's heard of Conway's Law, which is software and applications tend to reflect the organizational structure that created them. And I advise companies and customers that I talk to really think about how they're organizing their teams against the customer experience that they really want. So if anyone's ever had that poor experience of trying to consume multiple services from the same company, but having 2 different user accounts for 2 different services offered by the same company, or something along those lines, you know what that feels like. So think about how you want to organize your teams, but first think about what customer experience do you want your customers to have, work backwards from that, and organize your teams accordingly. So to finish, this is all really about turning infrastructure operations into platform architecture. So all of this helps you to think about creating and designing a system that gets your applications and your code to market to customers faster in an automated way, and then over time, taking the feedback that you're getting from customers, developers, and others, and feeding that back into the system, and changing the system to be better instead of changing an individual component, here or there to be better, all to enable focus on applications and what really matters, which is your customers, which is how we think at AWS. I know that's how CloudBees thinks too, which is why we partner really closely with them, because we share that philosophy of focusing on customers, all of you working backwards. So I'll finish up. This is, in any good presentation, I tell you what I'm going to tell you, I tell you, and then I tell you what I told you. So this is what we talked about. And if you forget the 3 words on this slide, remember people, process, technology, and tie everything back to that. So hopefully you found this useful. I'll be roaming around throughout the day. I think I'll be at the booth a little bit here and there. My name's Justin Graham. Hopefully you enjoyed this, and thanks, and have an enjoyable second day of Jenkins World, DevOps World.
Thanks, Justin.
You're welcome.
Thanks very much.